some of these questions are pretty tough. All right, so that's what today is honors level Regents questions. I kind of contradicted each other there, but that's what I'm going to do with you today, honors level Regents questions. Let's start with number one. I don't think number one is tough, but it does lead into my second question of the day, which is kind of tough. So everyone look at number one for me. January 2020 exam. We got two sets. We got a set of parallel lines, FAD, and we have EHC, parallel to each other. And then I give you a couple angle measures. FAB is 48 degrees. And I also give you ECB, 18. And we're looking for angle ABC. Okay, angle ABC. Again, not a hard problem, but I want to make sure we're good on special angles formed by parallel lines, because they're either going to be congruent or supplementary to these angles. All right, let me start here. Anybody confident in any of those angle measures? Anybody confident in those angle measures? You want me to put down any? Notice I'm not doing numbers anymore because it takes time here. What's up, Matt?
BHC is 48.
BHC is 48 because those are what type of angle? I'll take it. Alternate interior. Alternate interior. Yep. So that's going to be 48 degrees. Thanks, Jeff. We're just going January 2020 now. All right. Yep. We're getting there now. You could actually find that angle we're looking for right now. I'll go over that fact in a second, but I wouldn't expect anybody to find it right now. What other angle are you confident in? Let's keep going. Any others as we build towards angle ABC? What other angles can you now fill in? Matt gave you parallel lines apply. Alternate interior angles are congruent. What other angle now are we confident in? Other angles we're confident in? Christina, we're on?
HBC is 118.
Yep. 118?
14.
114, yep. That's 114. Now everyone's good. They're supplementary because they form a linear pair, and we get to 66. All good? Real quickly, because I told you guys yesterday, I want you prepared for everything. So anything, little thing I can think of, I'm going to share with you. Right after Matt gave us that 48 degrees, because it's alternate interior with the given one, you could have found that angle right now. Let's just go over this fact, because I don't know if you'll need it or not. An exterior angle of a triangle Anybody remember that one? How can you find angle 1 is equal to, Ian?
Oh, the other two angles added together.
Yep, the remote interior, the non-adjacent angles added together. So when I say you could have found this angle right now, does everyone see that fact applied now? That angle is equal to 48 and 18. Not that you needed it to use it, because we just found out we could have found the other angle and said it was supplementary, but in case you need that fact, there it is. Questions with number 1? Because now it's going to get tougher. I wanted to do number 1 because it leads into number 6. Go to number 6, leads into 6. We got a trapezoid, another set of parallel lines, AB and CD, and some segment lengths. So why don't you label your diagram with the segment lengths? What's the length of AB? Right away, I think my fear is you're going to go into a deep, deep hole because you're just focused on that's a trapezoid. It's only got one property. One property. What is it? Trapezoid, one property. One pair of opposite sides parallel. Done. Don't start going into the diagonals, nothing. All right, there's no other properties. Now, I put the word isosceles with trapezoid. All right, different ballgame. But now that it's just a trapezoid, nothing else other than those two sides are parallel. That is it. So this is why I did number 1 with you. Give me a pair of angles now that are congruent. Matt.
BDC.
Yep, and?
ABD.
Good, there you go. Matt just gave us a pair of alternate interiors. Good start. Alternate interior, yes. Thank you. Alternate interior angles right there. And can't we say on the other side that BAE and ECD are also alternate interior? Makes them congruent. And heck, you could even give me the vertical lines without using the parallel. Okay, why did I mark those on the diagram? Where am I trying to get to? All right, this might not be a trapezoid problem, but since you have two pairs of congruent angles and two triangles, what do we now know about those triangles? Darn right, they're similar because of angle. That's where you need to go in this problem. Nothing to do with the trapezoid, everything to do with similar triangles. What does he mean? Where do you go with that? Well, if the triangles are similar, what do you now know about their sides? Watch your mouth. Sides aren't congruent, but they are in the same ratio. There it is right there. There it is. That's how you solve the problem, by setting up a ratio of the sides. So let's take a side in triangle AEB, X, the one we're trying to find. Underneath it, I always put the one that corresponds to it in the other similar triangle. So X corresponds with what side in triangle DEC? 10.5, good job. And now I need another side from the triangle that has X, which is 5.2. And a little trick here, right? You don't want to use 11.7. That's AC, not a side in triangle DEC. Instead of 11.7, I'll use, how about 6.5? Where do you get 6.5 from? 11.7 minus 5.2. So there are some tough problems. Nothing to do with the trapezoid, but everything you had to notice it was a similar triangle question. Issues? All right, before I get into the next tough one I want to do with you, I do need to do a quick note session here with you and going over a special segment. I need to go over a special segment with you that is found in both a trapezoid and a triangle. This special segment is found in both of these figures. Maybe some of you remember what the name is. Ready? What's that point right there? That's the midpoint, right? Midpoint of that side. And that is also the midpoint of the other side. Here's the special segment I am talking about. Anybody remember what that bad boy's called? When you connect the midpoints of two sides, the non-parallel sides of a trapezoid. Matt?
Mid-segment.
Good job, brother. Mid-segment. And the same is found in a triangle when I connect the midpoints of two sides of a triangle. That is also called a mid-segment. All right, let's go over. There's two facts about a mid-segment we got to know going in. Anybody remember any of the two facts about a mid-segment? Will?
It's parallel.
Yep, it's parallel to both the bases, and in the triangle, it is parallel to that third side. Yep. And what about its length? Doyle?
It's 1/2 of the bases added together.
You got it. Good job. It's equal to, let me just put A, B, C, D. It's equal to half. In the trapezoid's case, it's equal to half the sum of the bases. In the triangles part, it's half of the third side, so EG. All right. So I wanted to go over that before we got into this next tough one. Mid-segment, everyone good? A little review there. It can be found in a trapezoid and it can be found in a triangle. Just connect the two midpoints and you have a mid-segment. Also, too, the last Regents that was just given in January, they asked to construct a mid-segment. And that would not be found on our videos. You know why? How do you construct a mid-segment? Find the one of two sides. Find the midpoints by doing the perpendicular bisector. All right. So they did. See it. They ask it in a little bit of a different way, that construction. They ask to construct the mid-segment on the last regions. All good before I get to the problem we need? All right. Buckle up. Number 9. Number 9. Third period, and a little struggle here with this one as well. I got A, B, and D. Okay, everyone, anybody thinking now I'm marking A, B, and C, D parallel? This bad boy is a trapezoid at least. It's at least a trapezoid. Yep, me too. Ooh, we got some midpoints, E, H, and F. Make sure you know what they're the midpoints of, though. All right, AD, AC, and BC. I got 3 midpoints there. Okay, AB is 24. CD is 18. I got a 10 on AH. And we're looking for FH. Ooh. Well, here's what I'm starting to think here, and then I get lost. We said that that was a trapezoid, A, B, C, D. Is everyone with me that E is a midpoint of that side, right, DA? And F is a midpoint of BC. So that EF's got to be a what then? That's a midsegment of the trapezoid. I guess I could find its length by taking half of 24 and 18, but here's the issue. H is not the midpoint of EF. H is the midpoint of AC. So I was thinking maybe I could find EF and then cut it in half because H is the midpoint, but it's not the midpoint of EF. It's the midpoint of AC. So that didn't help me out. I thought, all right, I guess I can add 10 to the diagram here because H is a midpoint of AC. And then I'm going to have you guys, I'm going to stop talking and see if anybody can see anything. I wanted to find the mid-segment EF, but that wouldn't help. I don't think that would have helped because I can't cut it in half. Because H is a midpoint of AC instead.
Because you said that's not the way to find it. Just cut it in half.
I can't. Why cut it in half? H is the midpoint at AC.
That those triangles are from here.
What triangles?
The
What?
CH and I don't know.
You better back yourself up. I only see a pair of vertical angles.
And then could you not do all interior angles?
What, these here?
Now, yeah.
Okay, they're alternate interior, but these are the lines that are parallel, remember. I would need this line parallel with this line here, right? These would need to be my parallel ones, which I don't have. So yes, they're alternate interior. No, they're not congruent. I don't have the right lines parallel. Aiden, what's good, brother?
You could do similar triangles. CH.
Okay, well, let's stop right there before you get ahead, because I you know how I roll in here. You better prove yourself. Where's your angle to say they're similar?
CAB and BC and ACD.
Here and here.
Oh wait.
They're in, right? This one's got to be in that triangle, which it's not.
Yeah.
Okay, that's fine. That's fine. We're gonna get here without me saying anything. Maddie?
Similar triangles. CHF and CAB.
CH right here.
Yeah.
Oh, keep talking, Matt.
And then
Wait, what? Those are corresponding, right?
yeah.
Okay, so everybody knows. Are you talking about You're talking about triangle CHF and the big one, CAB. All right, make sure because I think some people thought you were talking about those two. Okay, so Matt's talking about the small one inside the big one. These are corresponding, but I need parallel lines for that.
Is it the mid-segment?
All right. That's what I was trying to push you towards. Yes, the mid segment is parallel to the other three. So everyone agrees EF, since it's a mid segment of the trapezoid, is also parallel to the other two. So that makes Matt's corresponding angles congruent. Where are your other pair for angle?
CFB or CFH.
The other two pair of corresponding angles, right? Okay, so is everyone good? These two triangles are now similar by angle. Everyone see the angle? And now what do you know about the sides, Matt?
They're in a ratio.
They're in the same ratio, so we could do it that way. Okay, everyone see it? What do I have? Matt, you want to set this up to your way? X over
X over
equals, what's another side from that triangle that's got an X?
10,
10 over, watch your mouth,
20.
20. Yep. There's one way. And then I'm just going to blow your mind showing you the other way. Good job, Matt. Does everyone see where he's getting the similar triangles from there, the corresponding angles, and why they're congruent? And what do you get, 12 there?
Yeah.
Okay.
Did you tell us that the line was parallel earlier? Or is that like a rule?
Which line, EF?
Yeah.
Yeah, that's a mid-segment rule.
Alright, okay.
You had to figure out that was a mid-segment of the trapezoid and then say, oh, it's parallel to the other. Yes. So we're getting 12.
Can you see reflexive?
Or angle C reflexive. Yeah, angle HCF reflexive as part of it too. Yep, angle. Are you ready for this? You had to see it. You had to see it for this way. What's F again? What's F? Midpoint, right? Midpoint is CB. What's H again?
Midpoint.
Midpoint of CA, right? Here you go. What's HF? That triangle I just highlighted, what is HF? Mid-segment. What's it equal to? Half. It's third side. Okay, that was a tough one because you had to see the triangle there. Everyone see it though, right now? All right, triangle CAB. HF would be a mid-segment, so it's half the third side. So we could get to 12 that way.
It seems so obvious though.
What?
It seems so obvious.
Well,
though.
once I highlight it, yeah,
I know.
but yeah. But at least there was another way to get to it. All right, that wasn't the only way that you had to see that was the mid-segment in that triangle. All right, everyone good? I told you they're going to be tough. Some of them are tough, and I'm not even done yet. 12. Here's another tough one. Mark up your diagram with those givens. Hopefully you're putting right angles at MTA and MTH, and hopefully hash marks on AT and TH. And here's where you just start getting frazzled. You look at the choices right away. Stop looking at the choices. Stop looking at the choices. Look at the diagram and go further right now. Stop looking at the choices because you're just going to get frazzled. Look at the diagram and keep going. What else do you know is true on that diagram? Let's go. What else is true? Ian,
MA is congruent to MH.
where are you getting that from? Because you're skipping like a couple steps. I want to get there, but you're skipping. Reflexive. What do I know about the two triangles? They're congruent by side, angle, side. Everyone's still with me. I'm doing like a mini proof right now in front of you. And now, Ian, I could say CPCTC, MA congruent to MH. What type of triangle is MAH? Isosceles. So that's why I'm going to get rid of number one because it says which one is not always true. Not always true. All right, give me something else. What else must be congruent if the triangles are congruent? Give me another pair of corresponding parts. So I'm going to eliminate another one of these up here. Zeev, go.
Angle A, angle TH.
Angle. Which ones?
When angle TMA and TMA.
Yes, TMA and TMH. Those two are congruent by CPCTC. That lets me eliminate number three. So because MT would bisect if that's true. All right, everyone all right on my eliminations? Now let's look at these last two, which are the tougher two. Which one is going to be always true out of those two? Take a peek out of those now. You know the triangles are congruent. CPCTC says the corresponding parts are equal. What's up, Ian?
Well, I guess it'd be 2 because it can't be 4.
Okay, let's go over why it can't be 4. Why 4 is always true. All right, guys, real quick. Which angle is congruent to A up here? A and H, right? Everyone's good? Angle A and angle H have to be congruent by CPCTC. All right, angle, where do I want to go now? Angle TMH plus angle H. TMH and angle H, what do you know about them? They have to equal what? 90, because I already have the right angle taken care of. With me so far, equal 90. We learned this thing called substitution way back in the day. If A and H are equal, take angle A, substitute it in for angle H. Now I know TMH and angle A have to be equal to 90 as well. The one that's not always true, I don't know how you're going to get two sides or two angles equal in that bad boy. There it is. Keep marking up your diagram. Keep marking it up. That's where students got frazzled, is probably looking at those choices. All good? I think I put this on the midterm. Not that you care, but I think this was on the midterm too. All right, I got one more for you. It's not a tough one, but it is a big trap. Number 21. It is not a tough one, but it is a trap. Well, it might be tough if you don't know the fact. For the acute angles in a right triangle, yeah, sine of 4x is cosine. Have we not done enough where once we see the sine and cosine ratios equal, because I know probably not, hopefully not all of you, some of you might set the 4x equal to, you'll do this, oh, they're equal, so I'll set them equal. And take a look, x equals 13, and there's the answer. Circle me. Come on. When are those two bad boys equal? Sine and cosine always equal if. Oh.
The things that have been.
What are the things?
I don't know.
The angles. The things. Sine and cosine ratios only equal if the angles are complementary. Their angles are complementary. So let's say you remember the fact. You are on top of things. You're like, let's go. It's always 90 degrees if sine and cosine are equal. I've done enough studying, practice problems. I know that. So I get 7x equal to 77. X equals 11. That's what I thought. There's the choice right there. You fell into the trap. Yeah, be great geometry students. What's going to get you over the hump to that 95 to 100 range? Even being better readers. Better readers. We're not looking for X. We're looking for the smaller angle. So I need to take that 11 and substitute it back in. Substitute it back in. .44 degrees. Better readers. That's devastating. That is devastating. That may be the only thing you get wrong on the entire exam, and you did it right. You just didn't read carefully. That's devastating. All right, we good? There it is. Let's get to work. If you want to work with somebody else, that's fine, but let's get to work here on these. You want to work with each other in your groups, talk loud, fine with me.